Okay, let's take a look at 17. Hey, it's Monday, everybody. Isn't Monday the best?
Yes.
My gosh. Like, I don't know what I'd do if my if my Mondays weren't so awesome every week. Like, Mondays are awesome. No. That is not the Tegan and Sarah I want to remember. You know, I never in my wildest dreams ever thought I'd see Tegan and Sarah at the Academy Awards. Tegan and Sarah. So weird.
I thought they were gonna perform like Selma, not Lego movie. They did all of the songs. Yeah, I wasn't paying attention. But like, you know what I mean? Like, I thought it would be like more like, not that.
Yeah, I don't know the Selma movie. I don't know the Selma movie. Alright, we have A naught is 1. A n is equal to 3 over n, a n minus 1. So I know it's kind of written as a recursive series. So I think what you should do is kind of write this out. Write out the series. So the first term is 1. Second term is 3 over n. Third term is 3 squared over n squared, right? Fourth term is 3 squared over n cubed. 3 cubed over n cubed, yeah. So, I don't know, the way I kind of think about it is, if they don't write the series out for you, they're probably trying to hide something. In this case, they're trying to hide that this is a geometric series, aren't they? You wouldn't really know that. So what is this? This is 3 to the n power. Oh, you know what? I'm so sorry. So sorry. 1, 2, 3. 3 to the n over n. Oh, I'm sorry. This is not a geometric series. Not geometric. Well, that's a problem. Okay, write the first 4 terms in a general term of the series. Okay, so that's part A, right? Let's kind of substitute all that in. Part B, what function f is represented by the power series? I think I'm still messing this up, aren't I? I really am still messing this up.
Where'd you get the power from?
Yeah, I'm still messing this up.
Wouldn't it just be 3 over 1, 3 over 2, 3 over 3?
All right, so let's take a look at the first term. The first term is definitely 1. The 0th term is definitely 1. Term 1 would be 3 over 1 times 1. Let's just actually write that. 3 over 1 times 1. The next term is going to be 3 over 2 times 3 over 1 times 1.
Why is there times 1?
Well, that's a previous term.
Oh.
Now, to get the third term, you're going to say 3 over 3 times the previous term. The previous term was this. So times 3 over 2 times 3 over 1 times 1 plus dot, dot, dot. I'm going to leave the general term until the very end.
Oh. I see.
Okay. So this is the first term, no, the 0th term, first term, second term, third term. Just kind of numbering them out.
How'd you figure that you multiply everything?
That's kind of what it says here.
Yeah, I don't get what the A and M is.
That means the previous term. Yeah, 3 over n times the previous term. This is recursive definition. Recursive definition. Okay, now we're ready to go. This is 1 plus 3 to the first power, yeah?
Yeah.
Plus 3 squared over 2 plus 3 cubed over 3 factorial plus dot, dot, dot plus. Let's number these again. That's the 0th term, first term, second term, third term.
It's like E.
3 to the n over
And factorial.
n factorial. Plus dot, dot, dot. Yeah. I hope you're seeing that as E. Really do. Maybe I should rewrite that. 1 plus 3 plus 1 over 2 factorial 3 squared plus 1 over 3 factorial 3 cubed plus 1 over n factorial 3 to the n plus dot, dot, dot. That's my function.
That's part B. We still didn't do
Oh, wait, there's no f. What am I doing?
we still didn't do A.
Oh, is that what you said?
That's it.
Wait, matter which way you don't have to plug in. Aren't the first 4 terms of the series, don't they have to have an x, a, n, x to the n in them?
But there's no x.
Yeah, there is.
There is an x in the answer?
Yeah. Yeah, 1 plus 3 is 6.
Sigma.
You're looking at 17, right?
I think let's just take this
Are we
problem
supposed
out
to
of
use
the
the
test.
sigma?
Mm-hmm.
Well, because in the power series it has the x to the
I think
n.
that x is just supposed to be.
So we're finding the first 4 terms of that series. Of the power series.
Somehow I can see.
Here's the thing. I don't see an x anywhere here.
If the power series says it's the sum from 0 to infinity of a and x to the n. I think it's a typo. It's just
It's a typo.
No, it's not a typo. Because these are the terms. I'm sorry.
We didn't, yeah.
This is A1. This is A0. This is all A0.
Yeah.
Yeah.
I'm so sorry. This is A1.
Yeah.
Okay. This is A2. Therefore, A2 equals
9 over 2.
3 squared
Oh, because we didn't do that thing.
1 over 2 factorial times 3 squared. This is A3. A3 equals 1 over 3 factorial 3 to the third power. So sorry for the confusion. Yeah. Again, we're just using the formula, the recursive formula, to figure out our values of A. Because they're clearly telling you here, A1 is 1. A0 is 1. They're clearly telling you here, any successive A is 3 over n times the previous A. That's a recursive definition for a sequence. And of course, as we continue this, we see that n is going to be 1 over n factorial times 3 to the n power. Okay. Patience.
Okay.
Jesus. Okay. Is everyone okay? We have all of we've figured out what A is. Okay. Next, we're told that we're told that the power series is A times x n. Right? So that's going to be equal to A0 times x0 plus A1 x to the first power plus A2 x squared plus A3 x cubed plus an x to the n power So again, this first half of what we're doing here is we're just figuring out the values of A. Are we looking? This first part up here, we're just figuring out the values of A. Once we have our values of A figured out, now we put them into the power series. So 1, 3x, 1 over 2 factorial, 3 squared x squared, plus 1 over 3 factorial, 3 cubed x cubed, plus 1 over n factorial, 3 to the n, x to the n. Does everyone see what we did? Okay. Let's rearrange that one more time. 1 plus 3x plus 1 over 2 factorial 3x squared plus 1 over 3 factorial 3x cubed plus 1 over n factorial 3x to the n power that should be it for part A. Part A. Part B. Does this look like any of the series that we already know? Well, e to the x is equal to 1 plus x plus 1 over 2 factorial x squared plus 1 over 3 factorial x cubed plus n factorial x to the n So it looks like the same series, except instead of using an x,
3 of
you're using a 3x. So this is e to the 3x. That's our function, e to the 3x. F of x equals e to the 3x. Notice as you're reading it says what function f is represented. And so f is e to the 3x to answer that question properly. Let's figure out f of 1. How many terms do we need to use? 4? F of 1 can be approximated by 1 plus 3 times 1 plus 1 over 2 factorial, 3 times 1 squared, plus 1 over 3 factorial, 3 times 1 cubed. So f of 1 can be approximated by, let's see, 1 plus 3 plus 9 halves plus, no, I'm going to keep that 9 halves, plus, what is this, 27 over
It's 9 halves.
9 halves? So f of 1 is approximately equal to 4 plus 9 is 13. What is the error?
Actual minus predicted.
Yeah, actual minus predicted. Which is equal to e to the 3rd power minus 13. Okay, so you're not going to have a calculator. So you can just leave it like that, yeah. Okay. I think at this point, with or without absolute value is fine with me. Okay. Any questions on C? Okay, part D. They made a very big stink, and it may not look like a very big stink, but it is. They made a very big stink, and they used this language right here. Exact value. What does exact value mean to you?
Actual.
Not an approximation. What else does that mean? Not, well, no, the series is fine, but not from a polynomial. If I could spell polynomial. Okay. Not from a polynomial. Not an approximation. So in other words, they want you to actually figure out what is f prime. What is f prime? Okay, you can answer this question. And this is the big trick. They kind of, you're using a part of a previous problem to answer this. You actually know what f of x is. It's e to the 3x. Which means you actually know what f prime is. 3 e to the 3x. Which means you actually know what f prime of 1 is. 3e cubed, yeah. That's that. You don't have a calculator, you can leave it like this. In terms of e, is perfectly fine. Even if you had a calculator, you can just leave it as 3e cubed. This fly is buzzing around me. It's kind of driving me crazy. Why does it like me so much? Any last questions on 17? I know I made a lot of missed problems in the beginning. I kind of worked it out, hopefully. Die. Okay, let's take a look at 16. I think this is the last one we're going to do today. (16) Okay, so what do we know? We know that f of t
2 over 1 minus t squared. And g of x equals the integral
From 0 to x, f of t dt.
Great. Let's find the first 4 terms of f.
Let's do it.
Okay, so what do we know about f? Hopefully you see what that is.
1
The
over
first
1
term
minus
is
t.
2 and the
1 over 1
ratio
minus
is
t.
t squared.
Is equal to 2. The ratio is
T squared.
t squared. What kind of series is it?
Geometric.
See, a geometric series. Good.
Yes.
Let me spell that correctly. Alright, so if you saw that as a geometric series, good job. Great work. So I just need to say f of t is equal to, how many terms do I need? 4. Okay. First term is 2. Second term is. Third term is.
2t to the 4.
Fourth term
2t
is.
to the 6.
Plus dot dot dot.
Plus t2 to the n. T to the 2n, sorry. 2 to the 2n. Shut up, sorry.
T squared to the n. And yes, please simplify that. F of t equals 2 plus 2t squared, 2t to the 4th, 2t to the 6th, 2t to the 2n power. Have it help you if you write that as 2 plus n power. I don't know why you would do that. I don't think anyone ever has, so I don't know why I'm mentioning it. Okay.
Just find the integral.
Great. Let's define the integral.
2x.
Part B. Let's kind of write this out. G of x is equal to the integral from 0 to x of ft dt which equals the integral from 0 to x no yes
That's not fair.
yeah I know it does
I don't think so. I've never tried it.
okay antiderivative it's the antiderivative of 2
2x.
2t gosh integral of t squared
2/3 t.
Alright, what everybody else said.
I'm going to try and write this really nice. Integral of t to the 4th.
2/5.
Integral of t to the 6th.
1/7 t to the 7th.
Plus. Okay, the 2 we can leave because that's constant multiplier. It's the integral of t to the 2n.
1/2n plus 1. T to the 2n plus 1. Close parentheses.
Oops. From 0 to x. Let's substitute x. 2x plus 2/3 x cubed plus 2/5. Let me make that 3 looks like a 3. 2/5 x to the 5th plus 2/7 x to the 7th plus dot 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 plus 2 over 2n plus 1 x to the 2n plus 1
Minus 0.
minus. Okay, are we sure it's 0?
Yeah.
Pretty sure.
Yeah.
Very sure.
Every term has a t?
Yeah.
Yes.
Yes.
Great. G of x equals, I'm going to do it again just to make do it again. There we go. Yeah.
Can you re-explain the general term?
Yeah. If you look here,
What is the derivative, the antiderivative of the
anti yeah. So the antiderivative is here, the 2 is constant, so that's why I keep the 2 here. The power here is 2n, right? So you always raise that power by 1. You add 1 to the power. That's why it's 2n plus 1. And then you divide by that new power.
Just making sure, so like, if the number, if the first term is like 2, you're always going to multiply the first term by like the
Upper,
ratio
well,
thing.
it should end up that way.
Okay.
Yeah. Are you saying like x minus 3, x minus 2, like that?
Like, if it would, if it was like 5 over 1 minus t squared, it would be like 5 t to
Say like 5 over
1 or like 1 minus x.
like that.
Yeah, and then so
Why didn't you
the
use
ratio
off
would
to
be
it?
like 5
And stuff. Why didn't you
5
use it?
times x to the
Yeah.
And stuff.
The general term.
or
You're right.
Approximation
What?
thingies, or are we fine with
If it's a series, then you don't. It's not an approximation. If it's a polynomial, that's an approximation. Okay. I think this afternoon we're gonna go through 1 through, hopefully 1 through 13.
Which ones don't we do in the study guide?
We'll do 14 and 15 in class tomorrow. Let me see.
doing 8, 12, 13, and 14 on the test book?
So yeah, for as far as 8 goes, we're not doing error. So don't do 8.
13 and 14.
12 is about remainder estimation, so yeah, you shouldn't use that one either.
Shouldn't or should?
Should not.
Which one?
Wait, hold on. Yeah, no, we're not doing the remainder estimation theorem. So not 12. Yeah, not 13.
Oh, I took your
Oy, and I guess not 14. Okay.
Does that mean we'd only be doing 15 in class tomorrow, or would we also? Are we getting pizza?
Yeah.
9, 10, 11,
Where do you guys use?
Yeah, yeah. Use the picket as a pass.
So you guys already got one. Oh, and two is concert hairstyles. Lemon 8.
Yeah, I think we can do this entire thing this afternoon. It's like 10 problems.
Yeah, I should really get.
Yeah, I think I'm gonna leave 15 for tomorrow though. Okay.
And if we had extra time in class tomorrow, if like we go over some of the problems we went over in review,